Okay, sorry about that, I got interrupted. So again, you want to make sure that the decimal you're entering here, the number you're entering here, matches the type of number here. So because this is a decimal, this one has to be a decimal. Infinities don't count, but the other number has to be a decimal because that's what you're comparing to. Alright, so let's run that normal CDF. To infinity, 0.15 and 0.0326. Sorry about the glare, 0.0204 should be your answer. Alright, so the question's asking, what might you conclude? So again, this is more what we're going to be doing in chapter 10, but anytime our answer, our final probability, is less than 0.05, so 0.0204 is less than 0.05, we have an unusual result. So it might mean that listening to music using headphones causes more hearing trouble than the general public, or it might mean that that 15% is no longer accurate because our sample was almost 22%. So when we have unusual results, we can either question the true proportion, that's one option, or you say that whatever special condition you were testing might be causing more or less of whatever you're trying to study. So when we get unusual results, something might be going on, and we'll talk about what kind of somethings that could be later on in chapter 10. Okay. The last page is just some extra examples. I think these are important because students, they don't struggle with this chapter, but it can be a little frustrating because you really have to pay attention to what numbers you're putting into the calculator. So it's not difficult, but it does require paying careful attention. So let's look at the foreign language example. So it says, according to a study done by Wakefield Research, the proportion of Americans who can order a meal in a foreign language is 0.47. So you'll see that keyword proportion. You also don't see a standard deviation. So that means that we're dealing with a proportion. It says, suppose a random sample of 200 Americans is asked to disclose whether they can order a meal in a foreign language, and it asks you to describe the sampling distribution, the proportion of Americans who can order a meal in a foreign language. Be sure to verify the model requirements. That's to make sure that the shape is normal. So in order to check that, we're going to do n times p times 1 minus p. Make sure it's at least 10. So we have 200 times 0.47 times 1 minus 0.47. And if I type all that in the calculator, that gives me 49.82, which is at least 10. So because that condition is met, we can say that the shape is approximately normal. That's verifying your model requirements. The second thing they want when describing the sampling distribution is the mean. So the center of all the sample proportions will be 0.47. And the last thing they want is the standard deviation, which is the square root of 0.47 times 1 minus 0.47 over the sample size 200. And I recommend typing that in the calculator, getting that 4-digit decimal. So the square root of 0.47 times 1 minus 0.47 over 200. Alright, in doing that, we get 0.0353, and we're going to use that instead of having to type that in every time. We'll just use that decimal. Alright, so we've made sure the shape is normal. That's your model requirements. We have a center and we have a spread for the sampling distribution. So part B says, in the sample obtained in part A, what is the probability that the proportion of Americans who can order a meal in a foreign language is greater than 0.5? So we're going to do a normal CDF. They gave us a proportion already, 0.5, and so greater than 0.5 would be 0.5 to infinity with a center of 0.47 and a spread of 0.0353. So again, the number you enter here needs to be a decimal because we're comparing it against a decimal. That's the biggest mistake in Chapter 8. So 0.5, infinity, 0.47, 0.0353. Gives us 0.1977. So about 19 or 20% chance that at least half of Americans can order a meal in a foreign language. And part C, would it be unusual that in a survey of 200 Americans, 80 or fewer can order a meal in a foreign language? So here, that's not a proportion or a percentage or a decimal, that's just X. So we have to do X over N before we jump into normal CDF. So 80 over 200, you want to actually divide that and get a decimal. In this case is a nice clean 0.4. It's 80 or fewer, so for our normal CDF, it will go negative infinity to 0.4, centered at 0.47 with a spread of 0.0353. Alright, so normal CDF, negative infinity, 0.4, 0.47, and 0.0353. You should get 0.0237, and the question is that unusual? And the answer is yes, that is unusual because it's less than 5%. So yes, that's unusual. And again, we'll talk more about this unusual stuff later on in Chapter 10. Alright, credit cards. According to creditcard.com, 29% of Americans do not own a credit card. So 29% means we're talking about a proportion. So our population proportion is 0.29. Suppose a random sample of 500 adults is asked, do you own a credit card? Describe the sampling distribution for the proportion of adults who do not own a credit card. Alright, so shape. To figure out the shape, we need to do n times p times 1 minus p. Make sure it's at least 10. So 500 times 0.29 times 1 minus 0.29. Make sure that's at least 10. That gives us 102.95, which is definitely at least 10. So our shape is normal, normally distributed. Then we need our center. The mean of all the samples will be 0.29, and the spread for the samples will be the square root. 0.29 times 1 minus 0.29 over sample size 500, and let's get a 4-digit decimal for that. Again, make sure on the older calculators, make sure to close that parenthesis right there. Then get to do so in the new calculators as well. And then there's our result. So our spread is 0.0203. So we're going to use that spread to answer these questions. Alright, the first question says, what is the probability that in a random sample of 500 adults, more than 30% do not own a credit card? So they're giving us a percentage, which means we don't have to do x over n. They've already done that. 30% is what we're working with. So normal CDF, more than 30% would be 0.30 to infinity. Testing against the mean or center of 0.29 with our adjusted standard deviation 0.0203. So normal CDF 0.3 to infinity, 0.29, and 0.0203. Gives us an answer of 0.3111. Part C, what is the probability in that same random sample size between 25% and 30%? That should say do not own. There was a typo in the old edition. I don't think it carried over. It should say do not own a credit card. So we're focusing on do not own. Alright, so normal CDF. Between 25% and 30%, these are both already percentages, so we don't have to do anything except convert them to a decimal. 0.29 and 0.0203. Just crunch the numbers. This is pretty easy if you don't have to do any division first. 0.25 to 0.3. 0.29 is the center, 0.0203. That gives us 0.6645. It's kind of the center of the curve, so it's going to be a pretty big percentage. And the last question, I want to show you guys how this is different. Would it be unusual for a random sample of 500 adults to result in 125 or fewer who do not own a credit card? Now, notice in part B and C, those are percentages. Part D just gives you a number, so you have to be very careful to catch that's X. Before we do anything, we have to do X over N. So it's 125 out of 500. So you have to be very careful to catch that before you start. Just takes a careful eye and paying attention to what those numbers represent. So that's a proportion of 0.25. That's what we're going to use in normal CDF. So, or fewer, so negative infinity to 0.25, centered at 0.29 with a spread of 0.0203. Normal CDF, negative infinity, 0.25, 0.29, and 0.0203. 0244. And the question says, is that unusual? Again, anything less than 5% is considered unusual, so we would say yes, that is unusual. And we'll see why that's so important at the end of the course. Alright, this last example is really important. I want to make sure the camera captures it. This is a very good question, and you're going to see at least one of these on the homework. I want to make sure you know how to work it. So, it says, researcher studying public opinion of proposed Social Security changes obtains a simple random sample of 50 adult Americans and asks them whether or not they support the proposed changes. To say that the distribution, the sample proportion, is approximately normal, that's what we're focusing on. We want it to be normally distributed. How many more adult Americans does the researcher need to sample? So, we know the formula is N times P times 1 minus P has to be at the very least 10. So if he knows that 10% of all adult Americans support the changes, we're going to use that proportion in here. We're going to solve for N. He already has 50 in his sample, and we're trying to figure out how many more to reach that target number of N. So it's a little bit of algebra. It's pretty simple. So again, for part A, we don't know the sample size we need. We know the proportion is 0.10, 1 minus 0.10. We know the bare minimum it has to do is equal 10. So if we do 0.10 times 1 minus 0.10, that gives us 0.09. I'm sorry, I should have spaced these out a little bit better. We'll do a little bit of that. So N times 0.09 equals 10. And the only algebra here is just dividing both sides by 0.09. So 10 divided by 0.09 gives us 111.1 repeating. So N equals 111.1 repeating. Now I can't have 0.1 of a person. That does not make sense. So because I need a little over 111, I actually have to round all the way up to the next number of 112. So we need a total of 112 people, We already have 50, so we need 62 more people. So it's a kind of a two-part question. The first thing you have to figure out is how many people do you need in your sample. Whatever number you get, if there's a trailing decimal, no matter what that decimal is, you have to round up. And then if you already have 50 people, they're trying to figure out how many more you need. So you have to subtract what you need by how many you have. And the answer that it's looking for is 62 more people. Now we're going to do the same thing if 20% of all adult Americans support the changes. So n times 0.2 times 1 minus 0.2 has to be at least 10. So now I'm going to do 0.2 times 1 minus 0.2. So n times 0.16 equals 10. And then we're going to divide both sides by 0.16. Again, just very simple algebra here. 10 divided by 0.16 gives us 62.5. I can't have half a person, so I'm going to have to round all the way up to 63. So I need to round up to 63 minus the 50 we already have gives us 13 more people. So they want to know how many more people do we need to ask. So you'll see that problem on your homework, and I just wanted to go over that here so you can see how to work it out. And that's it for Chapter 8. This homework's pretty short. Just pay very careful attention to whether or not they're giving you a percentage or decimal or an integer. That's really important for this part of the course.